Alright guys, welcome back to the channel. So we're going to do something a little bit different today. We're going to kind of merge my daily job with what we do here on the channel. So if you are on open source tuning and coming from Cobb, most likely you were like me, and one of the biggest detractors of that move was the loss of the access port, loss of the ability to monitor some of the metrics on your car in that nice interface. So if you're like me as well, you've probably done a bunch of research and identified that the best solution that really makes any sense, at least right now, is the Android application BTSSM. So that is the route that I decided to take. And if you are on an older Subaru 2014 or older, then you've got great support through BTSSM. But if you are on a 2016 or newer, I'm not sure what the support is for 2015, to be honest. But there's no support for VA chassis on BTSSM, and the developer doesn't seem to be actively adding ECU definitions anymore. So before I went through all of this, I did try and reach out to the developer in a multitude of different ways to see if he could add the definitions for my car, or if I could help add the definitions and potentially help develop the application as well. I think there's some opportunities in the application that I could definitely help with. Unfortunately, I haven't heard back from the developer for quite a few weeks, if not months now, and I wanted I wouldn't say first party support, but I wanted full support for my ECU in the application. So what I did is I went ahead and did a very light reverse engineering, guys. I'm not trying to oversell what I did here, but we did do a bit of reverse engineering on the application, and I did figure out how to add support for any ECU ID as long as you have the logger definitions, the memory addresses for your fields. We should be able to add support for any ECU ID to BTSSM. So that is what we're going to do today. I'm going to walk you through how I added support for my 2019 STI running Dimemod. We're going to add some permanent Dimemod logging fields to the build as well. And I'll kind of give you a brief rundown on how I reverse engineered the application. We won't go too far down the software engineering side. Let's get into how you can actually do this. So it is quite a few steps. I've got it in 20 steps. Now, if you are already an Android developer, you'll be able to skip some of these steps because you already have some of the stuff installed. I'm not going to go super in depth on all of these, guys. You may have to do your own research or your own troubleshooting. I am happy to help in the comments, but we're not going to go super in depth on every single step here. So, but like I say, if you do have questions or comments, or drop them in the comments, and I will do what I can to help you guys out. So first thing is you need a tool called APK Tool. You can download it from apktool.org. You need to install APK Tool. It does have a little bit of more software engineering type of install, I guess, a more technical install. There's no binary or anything like an executable. You have to download it and then move it to a specific location. Follow the instructions on the install guide. When it's working, you should be able to go to a terminal and type APK tool, and you should get output. Let me show you what that looks like real quick. If we go to a terminal and type APK tool, we get output. So that's how we know that APK tool is installed correctly. So the next step is we need to get access to the zip-align tool and the APK signer tool. Now these are included as part of the Android Studio for developing Android applications. If you're like me and you don't develop Android applications, at least not yet, and you don't want to install Android Studio, you can install just those command line tools by installing the command line tools at the bottom of this URL. You extract the tools to a location, and then you need to add the tools to your path. This is an example that I've highlighted here of the path that I added for my Windows computer. You can see where I downloaded the command line tools and I extracted them. That's kind of what that should look like. And then same thing if we go to a terminal and we run zip-align, we should get output knowing or telling us that we have zip-align installed. So now we've got our dependencies installed and we can actually decompile BTSSM and view the source code. So we're going to use APK tool to do that. First you need to download BTSSM. So now what we're going to do is we are going to actually decompile the APK into the source code so that we can look and find where the ECU definitions are stored and add our own. So to do that, we are going to use APK tool. So from a command line or a terminal, I'm using PowerShell, you need to be at the location where your copy of BTSSM from the BTSSM website is. So if we ls here, you can see BTSSM 2025.01.01.apk. So we are going to decompile it here. I'm just doing this all from my desktop. So APK tool, decompile, our input, and then our output is going to go to BTSSM-decompiled. Going to run this, shouldn't take too long. Alright, so now if we go look at our desktop, we have a BTSSM decompiled folder that contains the structure of the application. So now what you need to do is you need to identify what your ECU is, because we need to pull the last character off of the ID to add to BTSSM. For me on Dimemod, this AE5T201V was my ID, and we need the last character on that ID, which is V. So now we can open up the file that contains all the ECU definitions for ECU IDs ending in V, and that is located at BTSSM decompiled /assets/ECU v.enc. So I have another, this is the original decompiled folder that I was working with. You can see here, if we open that up, we get a bunch of strings here. So if you're an engineer, you may look at this and immediately notice what these strings actually are. If you're not, then you probably have no idea that you could actually do something with this. These strings are actually just base 64 encoded. So if we take these and we take them over to a website, I use this all day, every day at work, and we paste them in, and we make sure this decode each line separately is checked and click on decode. You can see that now all of a sudden we have a bunch of text here that actually means something and is useful and will allow us to add our car to BTSSM. So, if we go back to our steps here, we've identified the last character, we've opened the file, we've decoded the file. Now we need to add our lines for our ECU to that file. So, what you can do here, and this is what I did, is I took the ECU ID that was the last one in this file. For me, that was AE5Q100V. And I took everything that was under AE5Q100V. I took all of these, I copied them, and then I just pasted them down and I essentially duplicated them. And then I went through and I updated my ID in the first column. Because essentially what we want to do is we're just going to inject our data into a known good configuration, if that makes sense. So we will paste in AE5Q100V, all of those rows, then we'll do a replacement and we will update the ID to be your ID. Keep in mind, yours may be different. Like I said, this is the one that I have for my 2019 STI running Dimemod. And then you will need to fill in this top row. You can get this ID from your ECU definitions. So then you can go in here and you can put in the domestic market, the model year, the model, the submodel, the transmission. I'll be honest, I have no idea what these last columns are. I just kept the values from the 2014 STI above, and it seems to work fine. So now at this point, we have our first row all configured for our car and our ID. We have our ID updated on all the remaining rows. So now is the fun part, and it takes a little bit of time, but you need to go line by line and you need to correct any of these memory addresses that are different for your car based off of your logger.xml. So what do I mean, or how did I do that? If I take this memory address and I copy it and I go over to my logger.xml and I search for it, you can see that there's only one match in here, and it's for AF sensor number 1. If we go back to ECU defs, this is for AFR. Now, one thing that does kind of suck is he took I don't know if it sucks and it makes sense, but he took some creative liberties in naming stuff, so you'll kind of have to just put 2 and 2 together here. He has this labeled as AFR, but in RomRaider logger, this is AF sensor number 1. Makes sense. It's relatively straightforward. So you can also see this is a little bit confusing, but he also has them separated, so the lambda version of this field is its own row, and it is just a different type and has a different label, but it still uses the same memory address. So as another example, this is AFR target. So I think this is one I actually adjusted. Yep, it is, because you can see this is final fueling base. And if you look at the IDs here, and this is another way that you can do this, but this is one of our IDs. I think this is one of the ways that I did it as well, as I searched my logger for my ID, which would show me all of the fields that were unique or different to my car. And then I went and I looked back in the ECU definitions for those fields. To be honest, I'm pretty sure I went up and down and back and forth like 4 different ways to get everything filled in. However you want to do it, do it. Just know that what we're doing here is we want to make sure that for our ECU ID, we have the correct memory address from our RomRaider logger definition assigned to the field in BTSSM. So let's do one more. We'll actually do feedback not correction, because this one was huge and one of the main reasons I did all of this. So if we look at feedback knock, so you can see that this memory address is being used at engine load here, but there's 3 more, or a total of 3. So let's go to the second. There we go. So now we've got feedback not correction, and you can see that our ECU ID is in the ECU ID list, if you will, for this memory address on this ECU parameter / field. So you're going to go through all of these. You're going to update all of the memory addresses and fields so that they match for your car, and then you should be in a pretty good spot. Now, if you're like me and you wanted to add permanent custom fields like everything for Dimemod, then you can also do that. So this took quite some time here. You can get the memory addresses for your Dimemod parameters using Dimitri's website. I'm not going to go into necessarily how to do that, but you'll end up with a list of all of the different parameters and their memory addresses, and then however you want to do it, you need to convert them into this format. I use ChatGPT. I basically gave it the existing list, I gave it the list of memory addresses and names, and I asked it to merge the two together, and with a couple iterations of ChatGPT's help, I was able to get this nice consolidated list of Dimemod parameters. So I'm not actually using all of these because you do have to do some additional work to get these to go into the ECU, but primarily I did this so that I could get access to speed density and flex fuel, which I'm not running flex yet, but I will be. And I didn't want to add custom fields to BTSSM. I would rather just add them here since I was already here adding support for my ECU. So we may have skipped around. Let's go back to our steps here. We've added lines to our ECU. Now we do need to add our ECU to the ECU index as well. So there is an ECU index.enc file, and that is just right next to all of the other .enc files. Same thing, this is base 64 encoded, so if you take it into the base 64 decoder, we'll do it real quick just to show you guys. Decode. Now what this is this is just a list of all the various cars and all the different definitions that are in here to be used. So since we're adding a brand new one, we need to add one at the bottom. And you can see in the decoded that I already added one. This is also the first line from your definitions in this file. So if we go up and we look at the first line for mine, this is the line that you will add to the ECU defs at the bottom or near the bottom. I didn't put it at the very bottom, I put it where it logically made sense as the next ECU given the structure of the file. Yep, above TCU, above basic is where I inserted mine. So now you need to re-encode the index, ECU index. So that's pretty simple. You take it, you copy it, you come over here to the base 64 tool and you change to encode. You paste it in here, encode each line separately, you encode it, and now we have a string that we can put back into our file. So we would take that string and we would paste it back in the BTSSM decompiled folder structure in our ECU index.enc, paste it in there, save it. You're going to do the same thing for ECU V. So we'll come over here. I have mine labeled as ECU defs.txt. You may have yours different, but it is just the new definitions that we've added along with the old ones. We're going to re-encode them. We're going to come over here and we're going to paste them in and we're going to save. Now when you paste them in for yours, you're going to see new lines get added. Obviously I already have my new definitions added, so we didn't see new lines get added, but that's what you'll see for yours. Okay. Yep, so now let's talk about the additional work you have to do if you added permanent fields. So there is a file in the folder structure called gauges.txt, and this basically has a bunch of default values for how it should display parameters. So you can see for Dimemod, I added a couple down here so that they worked. This is Dimemod speed density effective final and Dimemod speed density effective base, I believe, Dimemod F, and then fuel pressure. So you just need to make sure that this ID lines up with the ID that you gave it over here. Yep, speed density VE final, speed density VE base. So now these values, luckily at the top of this file, we actually have definitions for the columns. So the field ID, min value, max value, notches, and label every num. I don't necessarily know what those do, so what I did is I looked through the list and I took values from something that was close and matched. So there was an existing VE, so I took that one. I had VE values over 100 at the time, so I made the max 150. Do that, don't do that, I don't know. It's your thing, you do you. You can always come back in here and change these as well if you figure out that something's not quite working right. But to get the gauges to show, there has to be a mapping and values in here for your new fields. All right. So at this point, guys, we get to actually build, like, that's it. We get to build the APK and we get to install it on the car, and it should work. So to build the APK, first you need to generate a key using KeyTool. If you don't have Java installed, then you're going to have to install Java. I'm not going to go into that here. If you are running RomRaider on that same laptop that you're installing this version of Java on, you probably want to avoid 64-bit, so you'll have 32-bit and 64-bit, and RomRaider will be mad. Figure that out on your own if you need to, or ask in the comments and I will try and help you. Once we have our key tool, we can actually build the APK using apkb command. So we will go ahead and run that. This won't take too long. There we go. So now, for the APK to actually install correctly, it has to be zip aligned. Took me a little while to figure that out. So then we can run zip align. And then I need to adjust this. I have a script that I use for mine. I'm not going to share this, even though you'll see a lot of it right here. I just needed to point it to my key store since I'm not in the same location. And then we use APK signer to actually sign it. That's it. So now you would go to the car, you would back up your BTSSM settings, you would uninstall BTSSM, you would transfer this new APK to your tablet or Android head unit, however, and install it, and then your ECU should be recognized. So let's talk a tiny bit of reverse engineering here. Like, how did I figure this out? So luckily it was pretty easy, because when you look at the decompiled application and you see under assets that it had all of these ECU files, that was a pretty big giveaway that these contained information that we needed. Luckily, I have enough experience that I looked at these strings and immediately knew that they were base 64 encoded, and was able to decode them and see that, man, this is it. These are our ECU definitions and our parameter mappings. Now, that wasn't enough though, because like I kind of went over, you have to put your ECU in the correct file, and that did take me a little bit to figure out. I actually had to go read some small E code, which is not something I've ever had to do before or had experience with, but it wasn't too hard. So we'll kind of go over real quick kind of how that came to be. So I've got two text files here, and I'll kind of walk you through how I found out what was going on. So the very first thing I did is I searched for ECU across the entire project, and there were only a couple instances where the text ECU was referenced. So since we know that those encoded files are ECU something.enc, we knew that if we found text that contained ECU, that one of those things that we found would be the right thing. So this is the correct one. So it has a constant string, so it starts with the constant string ECU. Then we're going to invoke a string builder so we know that we're constructing something here. And then what it does is oh, my cat's going crazy. It gets the last character off of the existing ECU ID using length. That's what this line does. Now, I'm not the best at smalling. I think it's actually a combination of, yeah, all of these lines. This top one is probably getting the ECU ID, saving it in a variable, then we're adding -1 to it, and then we're getting the substring from that. And then we are taking that value that's now in v5, and we're appending it to our string, which was E and C at the top. So now we would be, or it was ECU, so now we would be ECU V, and then it creates .enc. It appends that to the string, and then it uses Asset Manager to open an input stream. So that tells me that we are constructing the file ecuv.enc, and we are opening that file. So that is how I found out the hardest part of this, how the file is loaded and where you need to put the definitions. The very first time I did this, I just put my definitions at the bottom of ECUZ, and it recognized my ECU, but none of the fields were there and nothing was working. So I had to go back and try and figure out why my fields weren't being loaded, and was able to identify it reading this Smalley code. So I think that's it, guys. If you have any questions, drop a comment. If this was helpful in any way, like the video. If you'd like to see more software engineering content on this channel, let me know. We're primarily cars and dirt bikes and stuff, but you know, there is some engineering stuff we could do. If you're not subscribed, I would appreciate it if you would subscribe. Thank you so much, and I'll see you in the next one. Peace.